This video tutorial I will explain the difference between monolithic and microservices architecture. First we will see what is monolithic application. If all the functionalities of the project exist in the single code base, then the application is known as monolithic application. Designing monolithic application typically involves creating various layers like presentation layer, service layer and persistent layer. And the entire code base is usually deployed as a single var or a single jar file. In this context, mono refers to the single code base containing all the necessary functionalities. Here you can see the application which follows monolithic architecture, and it has single code base and it has three different layers: presentation layer, service layer and persistent layer. And the single code base is connected to database, and the top you can see the clients which communicates to the monolithic application. Now we will see disadvantages of monolithic applications. Over a time, monolithic application grows too big, making it hard to handle. Even minor changes require redeploying the entire application. As the application gets bigger, it takes longer to start up and deploy. New developers find it challenging to understand a large monolithic application, even if they are only responsible for small part of it. If one part of the application is heavily used, we have to deploy the whole application on multiple servers, which is inefficient and waste of resources. This makes horizontal scaling impractical. Introducing new technology suited for specific functionality is difficult in monolithic application because it impacts the entire application in terms of time and cost. A single bug in any module can crash the entire monolithic application, making it unreliable. Now we will see advantages of monolithic applications. Developing a monolithic application is easier compared to working with microservices because you don't need highly skilled developers to figure out and build different parts. Deployment is similar too because you only need to deploy one jar or one var file. Monolithic applications are generally easier and simpler to develop than microservices. Network delays and security issues are less of problem with monolithic applications compared to microservices. Developers don't have to learn multiple applications. They can focus on just one application. Now we will see microservices architecture. Here you can see three microservices. Each microservice is connected to its own database, and each microservice can communicate to other microservices. And in top you can see UI, which can be a front end or mobile client, and it can communicate to three different microservices. Microservices is an architectural development style. Applications are built using smaller services. Each service handles small portion of the functionality and data. Services communicate with each other directly. Lightweight protocols like HTTP are used for communication. Sam Newman defines microservices as small services that work together. In microservices architecture, the way applications interact with databases changes significantly. Instead of sharing one database, each microservice gets its own database. This might mean having some duplicate data, but it is necessary for keeping things separate and flexible. Having one database per microservice lets each microservice choose the best database type for what it does, which means one microservice can use Mongo database, another microservice can use Oracle database, and another microservice can use MySQL database, like that. Each microservice has its own secure boundary, so they can be written in different programming languages. For example, one microservice can be written in Java, other microservice can be written in .NET, and other microservice can be written in Python. Microservice architecture involves various patterns like finding services, hashing, handling communication, keeping an eye on what is happening, and making sure things are secure. Now we will see principles of microservices. The first one is single responsibility principle, which is part of the solid design pattern, which dictates the each unit, be it a class or method or microservice, should have one clear responsibility. In the context of microservices, this means each microservice handles a single responsibility. In other words, number of microservices should match the number of functions needed. Additionally, microservices typically have their own databases and contributing to decentralization. The second principle is building around business capabilities, which means leveraging the most suitable technologies for specific functionalities within the application. Unlike monolithic application, where using different technologies for various functions was limited. In case of microservices, which allows flexibility in adopting appropriate technology stacks or backend databases for each microservice. This ensures that each microservice can utilize different technologies based on the specific needs of the business. Third principle is design for failure. Design for failure in microservices means anticipating and preparing for potential failures within individual services. Unlike monolithic applications, where the failure of one model can bring down the entire system, microservices are designed to withstand failures. This architecture ensures that if one microservices goes down, other functionalities remain accessible to the users. And leveraging the resilience of microservices and minimizing disruption to the overall system. Now we will see advantages of microservices. Microservice is easy to manage as it is relatively smaller. If there is any update in one of the microservices, then we need to redeploy only that particular microservice. Microservices are self-contained and hence deployed independently. Their startup and deployment times are relatively less. It is very easy for a new developer to onboard the project as he need to understand only particular microservice, providing the functionality he will be working on and not the whole system. If a particular microservice is facing a large load because of users using the functionality in excess, then we need to scale out that particular microservice only. Hence, the microservice architecture supports horizontal scaling. Each microservice can use different technology based on the business requirements. If a particular microservice goes down due to some bug, then it does not affect other microservices and the whole system remains intact and continues providing other functionalities to the users. Now we will see disadvantages of microservices. Distributed systems like these microservice applications are more complex compared to monolithic application, especially as the number of microservices increases. Skilled developers are needed to work with microservices as they must understand and manage how the microservices communicate with each other. Deploying microservices independently is challenging. Microservices can be expensive in terms of network usage because they need to interact with each other, leading to network latency. Microservices are generally less secure than monolithic applications due to the communication between different services over the network. Debugging is challenging because control flows through multiple microservices, making it difficult to pinpoint exactly where and why the error occurred. Now we will see service oriented architecture versus microservices architecture. SOA emerged in response to the issues with monolithic architecture and gained popularity in early 2000. In SOA, a large application is divided into smaller services and deployed independently. But these services don't directly communicate with each other. SOA typically involves an enterprise service bus, which acts as a middleware or server facilitating communication between services using various protocols or message standards. And there wasn't any strict guideline for each service to have its own independent database in SOA. Microservices architecture is an evaluation of SOA. People also consider SOA as a superset of microservices. In simple term, microservices is a fine-grained SOA. Unlike SOA, microservices involve direct communication between the services and eliminating the need for central dependency like enterprise service bus, which is nothing but ESP. There is a guideline in microservices to maintain separate databases for each individual microservice. The core concept behind evolving from SOA to microservices is to reduce the dependency between services and promoting loose coupling according to the specified guidelines. Thanks for watching. If you like this video, please click on like button and please subscribe to my channel. You can get Java source code and PowerPoint presentation for each and every video. That you can see it in the description section of the video. Click on show more and here you can see the description and here you can see the links to download source code and PowerPoint presentation.